this explanation here, I'm going to explain regarding to exercise 28, 29, and 30. Okay? Now, let's say you have a quadratic equation, ax squared plus bx plus c equal to 0. Okay? Now, without working out, you can know whether it has, like for example, exercise 28. Okay? Exercise 28 asking you whether they have a distinct real root, equal root, or complex root. Okay? Now, I'm going to explain this part here. Now, you have the first case. Let's say we consider the first case where b squared minus 4ac is equal to negative, as I explained earlier in the other video. Okay? So if you have a negative, means conclusion is has the conclusion is the equation has two conclusion has no real roots. Okay? But it also means it has complex root. Okay? Isn't it contradicting? Okay? You say that if b squared minus 4ac equal to minus become a negative value, the equation has no real root. But then why it has a complex root? Okay? In the further part of the syllabus, in others, not the IG, A level, the square root, let's say b squared minus 4ac. Okay? Remember in the quadratic equation, quadratic formula, you got a square root, am I right? Now, if you are, in this case, b squared minus 4 is negative, so you have a square root, negative value, which according to the current syllabus, this is no answer. The IGCSE is no answer. Okay? Therefore, it say has no real root. But actually, if you go further, the higher level of max, this square root minus, it can be actually converted. Like for example, let's say minus 3. Okay, it can be converted into square root 3 times square root minus 1. Okay, let's make it easier. One would be, for example, minus 4. Okay, minus 4. Let's put a minus 4. Based on the current syllabus, square root minus, you don't have answer, so has no real root. But the higher level of mathematics allow you to look at this and arrange, organize it differently. Okay, so you got a 4 here, then you got a 2, but then you have a square root minus 1. Okay, they can actually change this square root minus 1. Let square root minus 1 equal to I. So, in other words, this actually become 2I. With the understanding I means square root minus 1. Therefore, in this sense, you have a root. You can actually use the quadratic equation. Use the quadratic formula, quadratic formula to work out the value. As long as you move the negative inside the square root to make it as I, okay, then you can get any value. But your answer will have a I, okay, using the correct formula. But then the higher level of mathematics call this as complex root, okay. But in IGCSE, you stop at this level here, okay. Therefore, you claim that there's no real root. But the higher level, even in SAT, other kind of syllabus, complex root is actually in the syllabus, okay. But this is just an explanation to make you understand. Even though we say there's no answer, but you can actually manipulate in such a way and then give a different notation. I mean, like square root minus 1 to become I. So that can be written as 2I, square root minus 4, 2I. If you have an I, any answer have an I in it is called a complex root. Okay? Now, that is the first part. The second part is b squared minus 4 is c equal to 0. Okay? Now, in this case, the equation has, okay, based on exercise 28, it has real root, okay, as a has equal real roots. Okay, now equal real roots, there's still a s. Okay, now what does it mean? Let's look at the quadratic formula. Okay, x equal to minus b plus minus square root b squared minus 4ac over 2a. Now, if b squared minus 4ac is equal to 0, that means this value inside the square root is equal to 0. So what does it mean is minus b plus minus 0 to a. Okay, so it becomes, okay, why there's a s has equal roots? Basically, it's the same root. Why? Because plus 0 and minus 0 doesn't make two different answers. Okay, it will still give you one simple answer, that is minus b over 2a. Okay, but actually this is actually plus 0, the other one is minus 0, but they are the same. So the word come in, the important word, they have equal root, they are equal. But actually there is still an s here to explain the two root, which is plus 0 and minus 0. Okay, if you do additional max, okay, real root, I mean equal real root means a curve and a straight line intersect at the tangent. The straight line is a tangent to a curve. Then you have this condition, b squared minus 4ac. Why? Because the solution, the x value, there's only 1 point. If there's only 1 point, means a curve intersect with a straight line. The only time when you have one intersecting point, if the straight line is actually a tangent to the curve. Okay, that's for additional max. But as far as max is concerned, has equal real roots means the answer is minus b over 2a. Okay, you get it? Now, the third cases is where b squared minus 4ac is equal to positive. Okay, now therefore in this case the equation has two distinct real roots. Distinct. Okay, they will be different from each other. Distinct real roots. The two roots are not the same. Okay, mainly if you are in this case you have a positive, then you have minus b plus square root, no, sorry, plus minus b square minus 4ac. Now, so if you have a positive b square minus, that means inside here, minus b plus minus, you got a positive value, right? So that is the answer for this. Because the plus is a positive value. Okay, over 2a, 2a. Okay, now, so there's two answers. First, you have x equal to the minus b. Take the negative. There's a positive value inside over 2a. Okay, that's the first answer. And then you have minus b plus positive over 2a. Okay, this negative minus square root is plus. So this answer and this answer are totally different. They are not equal. Okay, and they are actually real. Therefore, you have a real root, and there's an s here because there's two different values. Okay, and they are actually different from each other. That's why the word distinct. Okay, so hopefully this will help. If you read carefully still don't understand, can always ask me. Okay.